My name is Brandon Southall. I'm a research scientist with Southall Environmental Associates and the University of California, Santa Cruz. Also work with the California Ocean Alliance, and I'm specialized in bioacoustics, the study of sound and how animals use it and are affected by it. This project is a research project supported by the U.S. Navy, trying to understand the effects of military sonar on various kinds of common dolphin species. It involves an integration of several research tools that other people have used but haven't put together in a combination like this. There's really 5 elements to the study. We look on a very fine scale of movement with a drone that's above a focal group. We're listening to the group, the whole group, on kind of a middle scale. We have observers either on the bow of the boat or on the shore side that are looking at the broad scale of overall movement and configuration of groups. And then we have a sound source vessel that at a certain period of time when we're monitoring with all of those tools plays a sound that simulates a Navy sonar, or in some cases we can use an actual military sonar in coordination with the Navy. And then finally, after the experiment, we take tissue samples to look at stress hormones, specifically cortisol in the blubber of animals that have been either exposed or we know they haven't been exposed to sonar at a specific time. As the first experimental study that's measured behavior and changes in behavior of these large group, gregarious, social dolphins that can occur in hundreds of animals, we're providing first some just baseline information about how fast do they swim, how often do they come together and split apart, but we're also providing some applied information about behavioral response at different levels and in different contexts of sound. That gives information to the Navy to understand the impacts of their activities, as well as regulatory agencies to effectively manage those impacts and reduce those impacts. It's also providing information to people that study like longer term consequences, population consequences of behavioral responses, to look at how if these kinds of changes happen, what if they're repeated multiple times. And by understanding how they respond, it can enable us to better inform adaptive management to reduce impacts through mitigation, time mitigation, potentially changing aspects of different kinds of signals. We're seeing clear changes in their behavior, both on immediate, like seconds, over up to tens of minutes and even hours long. So we know that these things are changing their behavior. Now we're sort of refining the ability to understand, how long is that lasting, how is it persisting, and through some of these population modeling kind of efforts, what that might mean in a longer term sense if these things are repeated multiple times. So it's just refining our ability to quantify impacts and provide an informed way to better manage and reduce them.